Welcome back, everyone. Today, we're jumping right into a really fascinating explainer based on a specific fish-keeping journal entry. It was published on June 12, 2026, by a super observant author named Ang. We're looking at a true micro-mystery today, one that perfectly shows us how much we can learn just by paying close attention to the environment around us. Let's get right into it and see how these tiny living creatures interact with their habitats in some pretty unexpected ways.
Okay, let's dive into this. The whole investigation kicked off when Ang was looking at some outdoor ponds and noticed something, well, highly unusual. Ang wrote that the bottom was remarkably tidy and clean. You can clearly see the EPF foam at the bottom. Now, you know as well as I do, if you've ever kept an outdoor pond, the bottom is almost never pristine, right? It's usually just covered in a layer of muck, algae, and organic debris, the whole shebang. So actually seeing the EPF foam base is a total anomaly. It's a massive break in the pattern. And honestly, a break in the pattern is exactly where the best science starts.
Which brings us right to the big question I want us to ponder alongside the author today. What on earth was keeping these specific fry ponds so incredibly clean? Ang picked up on a huge clue right out of the gate. See, the sparkling cleanliness wasn't happening everywhere. It was only showing up in ponds that housed very large populations of fry, the juvenile fish, and specifically the ones being fed really frequently. So no fancy mechanical filters doing the heavy lifting here. This was something entirely biological.
Let's move into Section 1, Uncovering the Cause, the Foraging Mechanism.
To wrap our heads around this pristine pond mystery, we have to look closely at the keeper's daily routine and the actual physical mechanics of how these tiny fish interact with their meals. The primary catalyst here, the type of food. Angle wasn't tossing in those light floating flakes that just sit on the surface. Nope, the daily routine involved small, sinking-type fish pellets. Because they're dense, any pellets the fish don't grab right away at the surface just plummet straight down. They hit the absolute bottom of the pond and essentially hide themselves in whatever organic litter happens to be down there.
And this brilliantly illustrates the mechanical breakdown of what happens next. First, those sinking pellets fall down and get completely lost in the debris. Second, the hungry cichlid fry follow their food down. But they can't just easily pluck the pellets off the bottom. They have to actively search for them. To pull this off, they fan the litter with their little fins. Third, as they fan that debris away, they expose the hidden pellets and chow down. Now multiply that process thousands of times a day across a massive population. They're inadvertently acting like a fleet of tiny underwater leaf blowers. They're clearing and tidying the pond bed all day long until it hits that pristine state where the bottom foam is fully exposed.
All right, moving on to Section 2, Fry versus Adult Behavior.
Now, what's really interesting about this slide is the stark contrast in motivation here. You might be thinking, fish forage for food all the time, why is this a big deal? Well, Ang notes that adult cichlids absolutely do exhibit this bottom-cleaning, fin-fanning behavior, but only under very specific circumstances. They do it when a breeding pair is ready to mate and spawn, basically clearing debris to make a safe, clean nest for their eggs. It's 100% driven by reproduction. But the fry? These juvenile fish definitely aren't mating. This behavior is happening in mass across the whole copulation, and it's purely driven by the hunt for food. The author was totally caught off guard. An action usually tied to the highly specialized, solitary task of adult reproduction was actually being used as an everyday survival tactic by the babies.
This brings us to Section 3, the density factor. Once the mechanism made sense, sinking food leading to fanning fins, Ang noticed one last, lingering variable about population size and its impact. Let's move to and see how this builds our understanding of natural variables. Ang actually had two separate populations of cichlid fry to compare. This setup basically provided a perfect natural A/B test to see exactly how population density altered the environment.
And the direct observation was crystal clear. The population with the higher density of fry definitively resulted in a much cleaner pond bottom. It makes perfect sense when you think about it. More hungry mouths chasing sinking pellets meant way more fins fanning the debris. That exponentially increased the tidiness of the pond. The sheer volume of the population literally magnified the environmental impact of their foraging.
So, the crucial point is, this leaves us with a fascinating open-ended question.
Does higher population density definitively cause cleaner environments? Well, in this highly specific micro-ecosystem, relying on a very specific type of sinking food, the answer was a resounding yes. These fish were accidentally maintaining their own habitat just by looking for a snack. But think about how this scales. How do other population densities alter their surroundings in totally unintended ways? I want to leave you with that open-ended scientific variable to ponder for your own future natural explorations. Keep your eyes open, watch for those breaks in the pattern, and remember, sometimes the most fascinating answers are literally hiding right at the bottom of the pond. Thanks for joining me for this explainer, and keep on learning.